All right, we are looking at surface area of right pyramids and right cones. So just a reminder, the surface area of any object is the total area of all the surfaces of the object. So it's like if you were going to paint it, what would you be painting? So let's look through. We've already gone through the formulas for surface area of a cylinder, prism, and sphere. So we'll just record them here. All right, so surface area, there's two circles, so 2 pi r squared, plus the curved rectangle, which is 2 pi r, that's the circumference, that's the distance around here, times the height. For this particular prism, it's going to be 2 times length times width, plus 2 times width times height, plus 2 times length times height. Okay, it really depends for a prism like this what the base is. For a sphere, remember it's 4 pi r squared. So if you took out that center, if you cut it in half, that circle there in the center, the surface area is equal to 4 of those if you wrap them around the outside. Okay, so for right pyramids, here's a net. You can see how it's kind of folded out. This is a rectangular based pyramid because the base is a rectangle. All the faces are triangles. 2 are the same here, and these 2 are the same. All right, so what is lateral surface area? So sometimes we might just ask you for that. That's the sum of the surface areas of all the object's faces, excluding the base. So do not include the base. So that would be the front here, the side, the back, the left. Lateral would not be this part. Okay, surface area would be all of those together. Okay, so just be aware of that. The lateral area of the rectangular base pyramid is the surface area of all 4 triangles. What do you notice about the slant height of the pyramid, I should say. That slant height there, okay, it's on the slant in the middle of the side there. That's the height of the triangular face of the pyramid, okay? And so we'll need that in order to calculate surface area. Okay, so our right pyramid has a square base with a side length of 10.2 inches. Slant height of one of the side surfaces is 15.3. Determine the surface area. So if you looked at sort of a net, actually I can do a square here. So let's say, I'll do it over here. So let's say I do this square, then we would have triangle. All of these triangles would be exactly the same. Okay. Now I'm freehanding it, so they're not necessarily all the same. Okay, but I've done it pretty close anyway. So side length is 10.2, so it's a square-based pyramid, so all of those are 10.2, and it says the slant height is 15.3, so that meets at 90 degrees. If I were to try to draw the pyramid, I'll just quickly do like this. So we'd have the triangle here, here, and going back. And so the slant height would be this here that meets at 90 degrees. Okay. So surface area. We've got 4 equal triangles now. So that's going to be the area of the base plus 4 times the area of the triangle, because they're all the same, because it's a right pyramid. So that means the apex is directly above the center and all the sides of the base are the same. So this is going to be 10.2 squared plus 4 times the area of the triangle. So the base of it's 10.2, the height is 15.3, and divide by 2. Now you can do this all at once in your calculator if you want. So 10.2 squared plus, and then what you could do, 2 goes into 4 twice, or you can just go 4 bracket 10.2 times 15.3, divide by 2, close the bracket, and that's 416.16. Says to the nearest tenth, so 416.2, and this would be square inches because we're calculating surface area. Okay, so that's what, just think about what it is if you folded it out, if it was made of paper, and then that's going to be 4 triangles that are the same. Okay, next one, a right pyramid has a rectangular base that measures 14 by 6. If the height of the base to the apex is 20 centimeters, determine the surface area. So, for example, if I did this, okay, there's my rectangular base. Now, I'd have my triangles here. Okay, again, not quite correct there. Compared, they have to be the same, right? But I'm just doing a quick sketch. So what we're given here is the height of the pyramid is 20. So that is nothing in the net that's shown. So if I want to graph, so maybe look like, not graph, we draw it, this, back, okay, and then, oh, that's not great. Just a sec. And then we would have going straight up, straight down. Okay, and so the vertical height there is, this is what is 20 centimeters. So that forms a triangle, and we need to get the slant height of that side part here. So this part here, we know this is going to be 6 and this is 14. Okay, but what is that side? Okay, well, if this whole length here is 14, then this would be 7. So in one of your triangles here, you're going to have 20 and 7. Now it's not to scale. Okay, now be careful. So don't make it 14 and don't make it 6. 6 is over here. All right, so then you use, so we'll call this S1 for slant height 1. Use Pythagorean theorem. And so S1 will be the root of 449. Now we can use our calculator, and so the square root of 449, and then we'll keep some decimal places, so 21.1896, so 21.1896. So this will be S1. Now let me do it in green, and I'm going to minimize that. Okay, so now if I look at the front, okay, to meet the front there, that's going to be this. These are kind of different scales. This should be shorter, but in any case, your triangle kind of goes back from there and has a 90-degree coming out. So if I rotated it, then this distance here is half of 6, which is 3, and the vertical height is 20. So now this will be S2. Okay. So S2 squared equals 3 squared plus 20 squared, which is 409 when I take the square root. And then decimal-wise, it is the square root of 409, which is 20.2237. Okay, so that's S2. So now we can calculate the surface area. I'll do it in blue. So now your total surface area is the rectangular base, so 14 times 6, plus there's 2 of these that are the same, so 2 times 14 times 20.2237 over 2, and then 2 times the smaller triangle, that's 6 times 21.1896 over 2. And we'll calculate. So 14 times 6. You can probably do it all in your calculator at once. These 2's will divide out. These 2's will divide out. So this will be, now what you can do, if you have a newer calculator, you can go 14 times and then back to the 20.22. Okay, and that's going to be 283.132. Then plus, and then 6 times the 21, enter 127.138. Okay. And when we add them together, if you have the capability, add the 283 and then add, I put 86, it's 84. Okay, so let me fix this. And then my answer is 494.3. Now I can round it. So 494.3. And what units is this? Centimeters. Centimeters squared. Okay. Now, it did say the nearest whole number actually. So 494 centimeters squared. Okay. Okay, so surface area of right cones. Think about the surface area of a right cone. How do you make it? Well, if you take a big piece of circular paper and cut out a sector, then you can fold this up so that these touch each other. And that's really like this line here. So it forms a cone. And then, of course, you need the base of it, a circle at the base. So this side, this kind of slanted side, is part of a circle, a bigger circle than the base, and we call that the lateral side, and then we calculate the lateral area. So how do we figure that out? So begin with a square base pyramid, such as the one on the left below. So there are a few ways of figuring it out. This is just one of them. So this is basically from starting with a pyramid. So begin with a square base. The lateral area is made up of the 4 triangular sides. If the number of sides in the base is increased, then the number of triangles making up the lateral area is also increased. Keep increasing the sides in the base, and eventually the sides are so small that the base actually becomes a circle, and the lateral area of the cone is formed. So each triangle in the lateral area of the shapes has the area base times height divided by 2. In this case, the height is the slant height S. Now, be careful how you say that, because that's not nice to say those letters like that. Okay, where B is the length of each side in the base, and S is the slant height. So for the four-sided base pyramid, the lateral area has equation 4 times base times height divided by 2, which simplifies to 2 times the base times the slant height. So this we can just show, so this is really switched around, right? So I can show this as 4b so that we get the same as this. And what's 4b equal to? Well, if it was a square to start, a four-sided base pyramid, then this is really the perimeter of the base, okay? Oops. So the lateral area is 1/2 times S times the perimeter of the base. That's sort of a shortcut. You may not always remember that. It's not on your formula sheet, so totally up to you. Otherwise, you find the area of the triangles and add them together. If it's a regular sided base, then all the triangles will be the same. If we extend now our thought process to each of the shapes shown, the same process occurs. Therefore, the lateral area of the cone is given by this. So remember, 1/2 S times the perimeter of the base, that's what we found up here. Perimeter of the base, if we're thinking about a cone, it has perimeter, really we call the circumference, right? Because it's a circle. So 1/2 S times the circumference, and then the 2's divide out, so you get pi r S. So that is the area of the lateral face of a cone. Okay, so in words is the area of the base. Oh, maybe that's not really words, sorry. So it's a circle. I'm just going to do that. Area of the circle and the lateral face. Okay, area of that using variables, so that's going to be pi r squared, and this is going to be it's going to be pi r S. Okay, and so this would be your S, and this would be your R. Okay. So an example, right cone has a radius of 3.5 feet. If the height of the cone is 6.7 feet, determine the surface area. So if you did a quick drawing, not great, but okay. The right cone has a radius of 3.5 and a height of 6.7. So we need that slant height. So we need to calculate that first. So S squared equals 6.7 squared plus 3.5 squared. And then S equals the root of that. So 6.7 squared plus 3.5 squared is 57.14. And so we square root is 7. We're going to have to use this again, so I'm going to go 3 decimal places, 7.559. Okay. Then, so surface area is going to be pi times 3.5 squared plus pi times 3.5 times that slant height. So if that's already in your calculator, just press times pi times 3.5. Okay, which is 83.117. Rounded. Then pi times 3.5 squared is 38.485. And then you can add them together without doing any rounding. The rounding's only on your paper. So 121.6. Oh, 121.60. And that would be square feet. Okay. And then example 4. A right cone has a surface area of 210, diameter is 9, determine the slant height. So we're working backwards. So our surface area equals, so now here the diameter is 9, so the radius will be 4.5. So it's going to be pi times 4.5 squared plus the lateral face is pi times 4.5 s, the slant height. All right, so you're going to want to subtract, first of all. Okay, so what do you get? So 210 minus pi times 4.5 squared is 146.383. And now to get s by itself, we got to divide by 4.5 pi. So those divide out. So I'm going to get s equals. Now be careful on your calculator. If you don't use the fraction capability, then you need those brackets. So 146.383 divide open bracket 4.5 pi, close the bracket. So 10.354. And then nearest tenth, centimeters. Okay, and then it also, so that's the slant height, and then it also says the height of the cone. That's the vertical height. So when you think about a cone, okay, so we've just found this is 10.4. We know the radius is 4.5, so we want to find the height. So we're going to use Pythagorean theorem. So the hypotenuse, I'll put in a few more decimal places, squared, minus 4.5 squared. So in your calculator, we have that answer. So I want to square that, the answer squared, and then minus the 4.5 squared. And that's 86.965, and then we want to square root that. So 9.3. So 86, what was that again? Sorry, 86.965. So H equals 9.3 centimeters. Okay. It's going to be shorter than the slant height because the slant height is the hypotenuse. So that's it.